Dear students, on the basis of observations of Rutherford's famous gold leaf experiment, some conclusions were drawn by him. According to Rutherford, the mass of an atom is considered to be entirely concentrated within the nucleus present in the center in the form of protons. But when it was discovered that nucleus has a greater mass than it could be accounted for by protons alone, it was understood that there must be a third type of subatomic particle which was present in nucleus responsible for its mass. Then in 1932 it was James Chadwick. He was doing experiments similar to Rutherford's experiment. He was doing bombardment of alpha particles but on a different metal, beryllium, a metal with 4 atomic number. And he discovered a new type of particle with no charge and mass similar to that of proton. As the particle has no charge means neutral, therefore he named these particles to be neutrons. After discovery of neutron and in the light of the atomic model of Rutherford, then corrections done by Niels Bohr, then several scientists added time to time in the knowledge of atom, and therefore now we have a clear model for an atom which is known as modern model of an atom. According to this modern standard model of an atom, we have these main properties. First, an atom consists of subatomic particles called electrons, protons and neutrons. These particles are part of invariably atom of each and every element with only exception of hydrogen, which has only proton and electron but no neutron. Second, most important thing is that their atom consists of 2 main parts. First is nucleus. Nucleus is positively charged central part of the atom containing protons and neutrons. These protons and neutrons being present in nucleus, that's why collectively they are also called as nucleons. Then the positive charge of the nucleus is due to protons present in it, and protons remain unaffected by the neutrons because neutrons are chargeless. Then the second point is that the orbit or the shell is the second part of the atom. Orbit or the shell are the imaginary path traced by electron in the empty space around the nucleus, and as it was added later that these paths are not anywhere but they are associated with a definite amount of energy, and therefore the circular orbits are also called as energy levels. Energy levels. The orbit closest to the nucleus is having least amount of energy, whereas the orbit farthest has the highest amount of energy. How to understand it? Have a look at this. Suppose this is nucleus of the atom having proton and neutrons, and these are the energy levels or definite path on which electrons revolve. It is seen that an atom can have minimum 1 orbit and maximum 7 orbits. And how do we name or label them? We label them as either 1, 2, 3, 4, 5, 6, 7, or we can name them as K, L, M, N, O, P, Q. This is how we name them or label them. The numbering starts from the orbit closest to nucleus. The first or the K orbit or shell has the lowest amount of energy. The second one or L is having more. The third one will have even more. fourth even more, the seventh one will have the maximum amount of energy associated to it. Then the next point is that an atom is electrically neutral due to same number of electrons and protons. Electrons have negative charge. How much negative charge? Each electron has 1 unit negative charge. And what is the value of 1 unit? 1 unit means for atom and atomic particles, 1 unit of the charge means 1.6 into 10 to the power minus 19 coulombs. So suppose one atom, take any atom, suppose oxygen atom. Oxygen atom has 8 protons and 8 electrons. All atoms have similar number of proton and electrons. So oxygen atom will have 8 unit positive charge and 8 electrons will have 8 unit negative charge. So as proton electrons are separated from each other, protons in the nucleus, electrons in the orbit, and they have same amount of positive and negative charge which counterbalance each other. As a result, an atom is electrically neutral. Children, this is very important to know that though number of proton and number of electrons are same in the atom of each element, but no two atoms of different element ever have same number of proton or same number of electrons. So number of proton and number of electron in an atom is the characteristic property of atoms of that element. For example, atomic number, that is number of protons for an element like for oxygen, for atomic number is 8. But for carbon, it cannot be 8 ever. It will be something else. Like for carbons, atomic number is 6. Oxygen's atomic number is 8. So atomic number of two different elements is never same, and atomic number of all the atoms of the same element is always same. In the next video, we'll discuss these two important properties of atom: atomic number and mass number.